Okay, this week we are going to be talking about loops and exceptions. In this video, we're going to talk just about loops, and then I'll make a second video for exceptions. So the book goes through three types of loops: for loops, while loops, and do while loops. And so we'll go through each of those today. So we'll start with the for loop. For loops generally we use paired with arrays or lists, but we haven't learned about that structure yet. So we're going to use kind of a contrived example here. But basically, a for loop lets us loop through a block of code and execute that code a set number of times. And we can specify that number in a couple of different ways. So let's do something we'll create a factorial calculator. So in case you don't know, factorial, if we say mathematically 4 factorial, this is equal to 4 times 3 times 2 times 1, okay? Or 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So this is a mathematical construct called a factorial. Now, one thing you probably remember from math is that even though I defined 4 factorial as 4 times 3 times 2 times 1, we can also define this as 1 times 2 times 3 times 4, because due to the commutative property of multiplication, doesn't matter what order we multiply things in. 1 times 2 times 3 times 4 is the same as 4 times 3 times 2 times 1. So we'll take advantage of that to make our loop a little bit easier. So to build this, we're going to need two things. We're going to need a loop to help us execute each one of the mathematical operations, all the multiplication steps, and then we need a place to store our total. So our total variable we'll just create here. It's going to start out set to 0. And then to start out, we're going to say that our factorial, we'll just set it to 4, and we will make this more dynamic later. So a for loop has 3 components inside the statement, and each component is separated by a semicolon. So I'm just going to write these out blank here for a second. Our first section is a block of code that we want executed at the beginning of the loop, and it is called the initialization step. And this is where we will usually create and initialize our indexing variable, the variable we're going to use to keep track of what step we're on within the loop. Traditionally, this is written like this, and I equals 0. Okay? So what this says is from within the loop, we're going to create a variable, an integer variable called I, and we're going to set it equal to 0. Sometimes you will see people create the variable outside the loop and then initialize it at the beginning of the loop. This isn't very common to see. The other thing you'll sometimes see is you will see people use a different letter here, a different word for the variable. Sometimes people use index, sometimes people will say step. If there's some like very specific programming thing that we're doing and it makes more sense to use, like, I don't know, if we've got a list of books and this could be something like book index or book number. But traditionally, the most common thing you'll see here is I for the loop variable. It's just shorthand for index. And then if you have a nested loop, you'll see J and then K in the inner nesting. But we'll just use I for now. Now, most of the time when we do a for loop, we're starting with 0. And that's because we usually, as I mentioned, we use for loops with arrays. And that will make more sense when we cover arrays later. But in our case, since we're going to be stepping through this mathematical process, 1 times 2 times 3 times 4, we want our loop variable, our index, to start as 1. Okay? And so you can have the start however you want, but we're going to start it with 1. Okay, now this second block, the second section of our for loop statement is the conditional. Under what condition does the for loop continue to run? What has to be true for our for loop to continue? And in our case, we want our for loop to continue as long as this number, whatever step we're on, is less than or equal to our factorial number. So if I is 1, or if I is 2, or if I is 3, or if I is 4, we want the loop to continue. So we'll just say as long as I is less than or equal to whatever we're using for our factorial. In this case, that's 4. And then our final step, final block of code, is called the increment step. This happens at the end of every run through the loop. What do we want to happen every time the loop finishes? And what we want to happen is to say I is going to be incremented by 1. So this statement says take whatever I is, add 1 to it, and then set I equal to that result. So you can do all kinds of different things here. You could increment I by 2, you could execute some function, you could do whatever, but usually this is how you will see a for loop written. We have an I variable declared here for our index set to equal to 0 or to 1. We have a statement here telling us how to know whether or not the loop should continue running, and then what we're going to do at the end of each loop. So for now, let's just print this right line, and we'll say I is currently, we'll use our format here, I is currently, then we'll print the I variable. So what we're going to do is run this and see the output. Okay, so the first time we run the loop, we can see this I variable is set to 1, then 2, then 3, then 4, and then that's the end of the loop. So this is going to run 4 times because we said to keep running as long as I is less than or equal to 4. So it's good to step through this so you can kind of see the process that happens here. So when we first start, we have I equal to 0, okay, because that's just how variables start out their life. But immediately we're going to set I equal to 1. And then notice the first thing we do after we do our initialization step is we check to make sure we should run the loop. So it's possible for the loop to run 0 times if this statement is false. But we ask, is I less than or equal to factorial? It is. So we go into the loop body, we execute that line of code, we leave the loop body, we go to the increment step, we're going to increment I is now 2, and then we'll ask this question, should the loop continue to run? I is 2, 2 is less than or equal to 4, so the answer is yes. We execute the loop, we end the loop, do the increment step, then we ask the question again. Is it still true that I is less than or equal to factorial? That is still true. Execute the loop, increment step, ask the question. I is now 4, which it's not less than, but it is equal to factorial. So we execute the loop, print that, increment I, and now we ask the question, is it still true that I is less than or equal to 4? That is no longer true because I is 5, and so we exit the loop and we continue on, and in this case, that's the end of the program. So we execute the loop 4 times. We execute this block once, the very beginning, before we run the loop the first time, and then at the start of each loop, we check the conditional. If it's true, we execute all of the code here. At the end of the loop block, we execute our increment statement, and then we start again checking the conditional. So now, instead of printing this, let's go ahead and do our math. So total right now is set equal to 0. To make the factorial operation work, we actually have to set this equal to 1, because what we're going to do is say that total is going to be equal to whatever total was before times I. Okay, so we'll start out with total set to 1, we'll multiply it by 1, and that'll just give us this, 1 times 1, and then we'll multiply by 2, and by 3, and by 4, and we'll have our factorial. And then at the very end, we can print our answer. So we'll use the format string for this, and we'll say that something factorial equals total. This is what we'll print at the end. So let's go ahead and run that. See that in action. It says 4 factorial is equal to 24, which is in fact correct. And we can change this to be 8 factorial, and it will calculate that for us because it's using whatever number we put here as our loop limit. Okay. Now you may have noticed that we could take a shortcut here if we wanted. Since total is already set to 1, we could technically start our loop with 2. And you notice that when we do that, our answer doesn't change because we've already got the 1 times here. But it doesn't really matter because 1 times 1 is 1. So it doesn't change our answer. But more efficient to set this equal to 2. Okay. All right, so to review, we have our for loop. We can initialize a variable at the beginning that we use within the loop. It's important to note this variable that we didn't initialize here is only available within the loop body. If I tried to print it out here, I would get an error because I exists only within the body. I can have as many lines of code here as I want. This tells us whether the loop should continue to run, and this tells us what to do at the end of each loop. All right, so that is the for loop.